Right. Hello everyone. So this video is the continuation part of the previous video. The previous video what we were discussed about what is network flow and the capacity of the network flow and the current flow of the network flow. So these are what two things we were defined in the previous video. Now we'll be going to talk about maximum flow problem. Right. What is the aim of this problem? We want maximum flow from source to sink without violating the three properties of flow. The three properties are what? Capacity constraint and skew symmetry, flow conservation. In the maximum flow problem, we want maximum flow to be pulled out of the source and we pushed into the sink without violating these three properties. Now whatever three properties we were discussed in the last video, that will maintain this three in order to pull out the maximum flow from source and to push into the sink. Now we want these three properties to followed at the same time when we pass maximum flow into this flow network. Now, so currently what is the flow of this whole network? Now, to understand that, you have to look at into source. From source, what is the outgoing flow? It is from source to V1 it is having, and from source to V2 it is having. The flow is coming out from source to V1 to V2, and the flow value is what? 2 plus 1 is 3. So the maximum flow of this network is 3. How I have calculated? The maximum flow which is coming out from the source, right? And that is what? 1 and 2. The maximum flow which is came to T is also what? 2 plus 1, it is 3. Now the maximum flow of this network is what? 3. Now, so the question is what? The maximum flow, or is there any scope to increase the flow in this flow network? Sometimes it might happen that when you decrease the flow at any particular edge, at any one or two edges, your overall flow might increases. That it might take you more closer to the maximum flow that you wanted to achieve in this maximum flow problem. Our achievement is what? Our aim is what? You have to pull out the maximum flow from source and to push into the T. As of now, this network will give you the maximum flow which is 3. Is there any other figure what it can give maximum value? That the maximum value can comes if you decrease the particular edge. Now, is there any edge to this particular flow network where we can decrease it and increase the overall flow? Now, you can see that the edge, now I am taking that edge is what? From V2 to V1. V2 to V1 I am considering this, that it is my particular edge where I can decrease so that I can increase the maximum flow. Let's see. I am decreasing the flow value which is carried out from V2 to V1. Now I am decreasing with 1. That means already from V2 to V1 it is carried out which is 1. I am decreasing by 1. That means 1 minus 1 it is 0. So when I am decreasing this thing proportionally, I have to check whether flow conservation is maintained or not. Because in the beginning of this video only I said very clearly, in order to pull out the maximum flow from yes, has to be maintained, that the outgoing flow should be equal to the incoming flow. Now the incoming flow of this V2 is what? 2. Whether it is maintained, that you have to also check. Now from here also you please look at V1 is utilizing 2, but V1 is having what? From here it is 1 and from here it was 0. So to maintain this flow property, flow conservation property, increase this one value to 2. The reason why I have increased to maintain this property. Now, if you look at what is the maximum flow, maximum flow is what it is coming out of the S. Out of the S it is coming, it is 2 and it is 2. Maximum flow value has been increased by 1, which is 4. So in this case, I knew that if I increase this particular edge flow value, I can increase my maximum flow. But as this example is having only 4 vertices, it is easy for me to identify the particular edge whose value I have to decrease so that flow network value might have increased. This thing I knew, but it is not always true when I have the more number of edges. If I have 1000 edges, I cannot check which edges will give you this, and I cannot calculate also. So I need the other technique in order to know how the maximum flow can be increased, and that was the residual graph. Residual graph. What do you mean by this residual graph? The graph which will talk about maximum flow value, how it can be increased. So the residual graph is going to talk about residual capacity. So residual capacity will get calculated with the formula. That formula we'll see, and this is what the formula is. We'll calculate the residual capacity of each edge, and we will be going to find out the augmented path. The path, if it is existed to T from S, and this path will tell you what is the bottleneck capacity. That means what is the value which can be increased the maximum flow. Augmented path will give you that. Now let's talk in detail about how to draw a residual graph and what is the residual capacity. So residual graph is what? Here also we will be maintaining those 3 properties. Wherever I am showing the graph is having a capacity and flow in the flow network, there it has to maintain those 3 properties, which are capacity, skew symmetry and flow conservation. Now let's look at the residual graph. Residual graph will be having a residual capacity. Flow network is having a general capacity, and it is what residual graph. This graph will have a residual capacity. Residual capacity will be calculated through this formula. That formula is what? Capacity function or residual capacity of one particular edge is equal to capacity of maximum flow minus flow what is flowing. This is the formula. Now let's point out the vertices what you have basically. Now you start from the S. Now in the S, I have changed the value. Earlier with the maximum flow problem, we come to know this value has to be increased, this value has to be decreased. That we come to know with the general idea. But the general idea will not work when you have more number of edges. So the reason I'm introducing this residual graph with the residual capacity. That's what I have taken the basic values what were there earlier. Now, so from S to V1 there is a edge. Edge with what? Some flow value and some capacity value. So residual capacity, I told it is a residual graph which has to be maintain residual capacity. Residual capacity will be calculated with the formula this. That minus capacity minus flow value. What is the capacity? 3. What is the flow? 1. So now it is denoted as 2. So it is what? Residual capacity. And what is the maximum flow? Maximum capacity is what? 3. But I am utilizing only 2 from S2 to V1. So there is another path which is existed from V1 to S, which is utilizing the 1. Now the maximum capacity of this maximum capacity of this network is what? 3. Will it maintain? Yes. So in this path it is 2. In this path it is 2. In this path it is 1. You have to see in the same way. Now let's come to this V1 to V3. V1 to V3, what is the residual capacity value? Capacity value is 2, flow value is 2. 2 minus 2, it is 0. Correct? So when the case of it is 0, there will be no residual capacity which is traveling from the other, V3 to V1, only to V1 to V3. That only we will be pointing out. And now come to V3 to 2. V3 to 2, what is the residual capacity? 3 minus 2, it is 1. And the maximum capacity is what? 3. So there will be a other path which is traveling from T to V3 and which is 2. And next is what? Come to the other vertex. We'll see all other vertices with the same. So S2 to V2. S2 to V2 also we'll see. S2 to V2, it is 2 minus 2, it is 0. So there will not be any opposite path. V2 to V4, there is 1 to 2. That means 2 minus 1, which is 1. And the other path also it will be, which is 1. Because the maximum capacity is 2. So now 1 plus 1, it is 2. And V4 to T. So V4 to 2 also it is 2 minus 1, it is 1. So opposite direction also it will work, which is 1. So and there are other vertices. V4 to V3, 0 minus 3, that means of 2. So 2 will be here and 1 will be here. Now see about V1 to V2. V1 to V2 is what? 1 and 3. That is 3 minus 1, which is 2. The maximum capacity is what? 3. So there will be opposite direction, which is 1. Now, we're done with all the edges. We're done with all the vertices. Now the job is what? You have to find out the augmented path. What is the augmented path? The path which is existed from source to sink with the residual capacity. So that path is what? S2 to V1, V1 to V2, V2 to V4, V4 to T. The path is S2 to V1, V1 to V2, V2 to V4, V2 to V4, V4 to T. Now, what are the residual capacities? You please make a note. S2 to V1 residual capacity 2. V1 to V2 residual capacity 2. V2 to V4 the residual capacity 1. V4 to T residual capacity 2. Now, augmented path is existed with these residual capacities. Now find out the residual capacity which is minimum out of all. The minimum is what? 1. So this minimum is called as bottleneck. This minimum is what? Bottleneck value. This bottleneck value, whatever you got, it has to be added to the maximum flow. What is the maximum flow? Before you draw on this residual graph, it is 2 plus 1, which is 3. So the maximum flow what it can achieve through this residual capacity is 1. That means 3 plus 1 is equal to 4. So this is the way how I have to calculate maximum flow from S2 to T using residual capacity. Yes, so this is about residual capacity to increase the maximum flow which is from S2 to T. Thank you all.